Hi, it's been a while. I've been busy helping a friend out, but I've got back onto machining the uprights now. First incantations obviously had a few problems, a few errors, but purely of my own doing, programming, stuff that I'd never spotted in CAD, but when I did it in real life, needed some alterations. Now we have a pretty much finished G-code system which works really well. One thing I did do, which has taken so long, I've done a lot of manual programming to speed up the process. Bought a few extra tools to make things a little bit easier. All the chamfers now are done with the 45-degree tool, and are just done with the profile. Previously, if you kind of see here, there's kind of ridges in here and here. Well, that's done with a ball-ended tool, basically to make all these complicated shapes. But I was also doing the front face with it and these 45s. But I did a single point profile of each of the holes, and basically put a 45-degree tool in there and just measured the height to. I got the chamfer outside, which sped things up a little bit. But also the programming is very safe. A lot of Z moves to keep the tool out away, which basically meant I had to delete a lot of useless moves. If you move it from here to there to machine something, it would come up, back to zero, bound, then back in again. Now it goes pretty much just slightly clearance, rapid moves in, and then feeds in the last piece. But it involved a lot of reprogramming. So rear upright, all corrected, ran through in one go now. Fine, not a problem. This is my first front. Or was that the first one? Oh yeah, this is the first one. Yet again, they used the ball tool to make the chamfer, which made a lot of little moves, kind of chamfered off. Now I don't do that. Still use the ball to make this angle here and this angle here, because technically that's at not at a 45-degree angle, and that doesn't take too long, about 10 minutes to make those once they're roughed. This outside edge now is 45 degrees, so technically that chamfer is also done with a tipped 90-degree combined angle chamfering tool. So nice and simple. So that speeds things up here, and I've done a couple of prototypes, and sped things up, moved things around just to make things quicker. This one's ready just to break out. You start off with the back face. That's better. Start off with the back face, and you hog all of this out. Obviously that's a lot of aluminium to hog out, so you're basically using a 3/4 inch roughing tool, which is why it's got the serrations on the side. It lowers the side pressure of the tool, stops it chattering, and I can really hog it out with that. The only the only downside to it is if I can focus in the middle, it doesn't cut in the middle, so it's not a center cutting end mill, it's just basically a hogger. It will do a very gradual slope, so you can do a Z move. You can't plunge, but you can do a Z move down and kind of Z it, or Z shape it, if you need to get in where you can't. Obviously middle in the center is not a problem because the hole's out for the middle. So I altered all the programs. When it was a Z move, it was doing a plunge, I would move it clear, so it was, and then come into the sideways. Side cutting's fine, but it can't plunge mill, it can't do basically a direct in. Whereas if you look at we've got my 1/2 inch tool here, you can just about see that this tooth here does actually go all the way to the center. So technically this tool can do a pure vertical movement straight into the aluminium. You can go at a lot slower feed, but it'll go in. And you don't want to go massively deep. You don't want to go like 25mm in deep, because it's going to start to try and chatter and run round. But you can go in 10mm and then start doing some cutting. So it involves a lot of program changing, because unfortunately Meshcam doesn't recognise a non-center cutting tool, which is kind of awkward. So I had to, every rapid move I've had to make sure it's clearance, and sometimes it would wrap it into a corner, so I would have to feed it into the middle and would across, then come down. So it took a fair few hours altering the program, but now I've done this, started this yesterday. Yes, I replicate the round billets just to make sure I could get the clamps and everything right. So an 11-inch round billet does the front, and a 15-inch round billet will do the rear. But for the moment, I've just cut this out of square so I can do it here and make it nice and simple. So this is now ready just to break out. And you can just see in the corners here that isn't completely machined through, so that I can still get a nice finish on the outside edge as I'm just finishing it off. Skip it round, you can see it's pretty much all the way down. These are about 22mm thick, the flanges, and it's machined down to about 20mm. So there's a small tab about 2mm thick and about a half an inch wide, just to hold it in place. MDF will flex a little bit, you can probably push that a little bit. Aluminium won't flex as much. So now that's ready just to break out, without having to have a clamp for the centre. Actually, these aren't too bad for, I can do a full profile, I don't have to leave tabs to try and break them out, because this back face is completely flat, and that's one of the first ops you do to that side of things. So when I've done this face first, which is the first one, I'll stick it down, and the very last op before I go around the outside and trace the outside to break it out of the billet, I put a clamp in the centre, and I've actually got something to clamp against, so I can clamp directly to the floor, and that's fine, that holds a part in. I don't need to do these tabs. But if you can see this, I have to go back first because there's a lot of hogging. Well, the only thing that's actually at that one level is that one tab. So to try and clamp it, it's just not going to sit straight. This is quite a bit further down. So without having to make a little jig to sit in here, and it's not going to be right, and I wouldn't be happy with it. So I just left it pretty much in. And if we just give it a tap, this is MDF, so it should break out quite easily. There you go. Obviously, with the aluminium one, I'll have to cut it. But now we've just got a small tab. We'll have to just clean up there and just clean it up with a file. It's not a problem. There and there. So now we've got our front upright. There is one final op to do on it. Obviously, I've got to machine a hole for the top pin and for the bottom pin. Basically, I'll just bolt it up to a 90-degree faceplate and drill and just mill out the hole with a small cutter. I think the hole is about 24mm, so I can easily cut down there with a half-inch tool and then just machine it out nicely. So there we go, upright machining, one front, one rear. Upright machining now ready. So it's very dusty in the workshop at the moment for some strange reason. But she's pretty much done now. I'm happy with the G-code. I've saved it to a master file, made it so I can't delete it. I'm pretty happy with it now, so all I have to do now is pretty much bolt the aluminium in and hit play. So really happy with it. Made a few minor changes to this as well. Changed the radius in here just to make it a lot faster to machine. It was 10mm before. I just changed it to 6/3 to a 1/4 inch rad, so a 1/2 inch ball mill does a perfect surface on it. So the other things to make it easy to change. Obviously, this will have one more op on as well. Excuse that, was a mistake by me again, as usual. This is the mounting pads for the radially mounted caliper. These are that's the radially mounted caliper. So as you can see, pretty much the two bolt holes will bolt. Boom. There we go. Bolt there and there. So I'll have to set this back up and say bolt that up against the 90-degree face, and then drill and tap those in the right place. So they both have minor ops to do afterwards, but obviously I haven't got a 4-axis machine, so I can't hold it and then turn the part over to machine that. So there you go. I think might be a little bit too much asking. 4th axis is quite expensive. It's about another $3,000-4,000 to get a decent used one most of the time. So I shall not worry about that, just to make a one-up a little bit quicker. It's not worth the hassle. So uprights ready to the machine. Billets on order. They should be here Monday. Having to ship them in. The cheapest place was 3-hour drive away, so I'm going to ship them in. Also, Automatic. I've ordered a load of 8x4 sheets of NS4 grade or 5052, whichever way we look at it. Aluminum sheet, because I've got some bits and pieces I need to do. One thing I definitely need to do is when I've got the coolant systems all out and running. Look it on the front. Using the original pump, small inverter in there. I've also got half a dozen or so nozzles that I can tune. Valve, nice and simple, very basic, but I thought my nice return trays, one I built from the rear, the original return trays are in the back, and all the coolant returns in here would be enough. Obviously built a guarding system here, and there's another half of it here that slides on and just pushes into here. Unfortunately, I should have known better, coolant just goes everywhere. Albeit it's completely enclosed in here, it drips down to the edge, comes off, drips down to the bottom, comes off. The aluminum chips stick in the back and they fly off here because I just basically knocked this out, aluminum plate on the weekend, so I've got somewhere to organise the tools. So this isn't going to work as it is. I'll drill a few more drain holes to get the coolant out, but what I'm going to have to do, I didn't want to, but I'm going to have to build a nice tray that's going to basically come out about 18 inches from the base and then angle down to the coolant return. Obviously those are you can see the coolant return filters there. They go into the base and then the pumps inside. So basically I'm going to have to build that tray out make it 3 foot wider and 18 inches deeper this way, and then anything that drips off the side doesn't matter, it's going to go in the tray, it's going to go back. I'm not getting much splashing kind of around it, but I am getting lots of drips and stuff to the side, so so I'm going to build that out of the same sheet that I'll use to skin the car. Okay, 12 minutes, geez, I can rabble on. Right, okay, I shall speak to you later. When I start machining the first aluminum part, I'll make another little video, and when I pull the first part out, we'll bolt it all up to a caliper and a bearing, whack a rotor on it, and show it all bolted together. Maybe even bolt to the car. Sacre bleu. Okay, speak to you in a bit. Bye.